Hi, welcome to my channel. I'm glad you are here today. In this video, I'm going to discuss easy techniques to find the sign and values of all trigonometric functions within the four quadrants. Let's dive into the discussion. But first, let's start with the basic definitions of the trigonometric functions.
Alright, from the trigonometric definitions, sine of angle theta is equals to opposite side, which is y, divided by adjacent, which is the longest side of the right angle triangle, which is r. Similarly, for cosine of angle theta is equals to adjacent of the angle theta, which is this side, which is x, divided by hypotenuse of a right angle triangle, which is r. Alright. Tangent of angle theta is equals to, by definition, it's a sine of theta divided by cosine of theta. So if you substitute the above values here, y divided by r, or cosine of theta is x divided by r, x divided by r. So that means r cancels each other. So tangent of any angle theta is equals to y over x, which means opposite side divided by adjacent side. Alright, the other trigonometric functions that we have to see here is the reciprocal of sine of theta. That means 1 divided by sine of theta is equal to cosecant of theta. So cosecant actually is designated by cosec of angle theta, which is r over y. That means hypotenuse divided by opposite side. Alright, the reciprocal of cosine is 1 divided by cosine of angle theta, which is called secant, or it's designated as SEC, which is sec theta. That means r over x. So the reciprocal of tangent theta is 1 divided by tan theta, which is cotangent, COT, or theta, or cot theta, is equals to the reverse of this value, which is x divided by y. So the reason why I'm defining the trigonometric function here is that we are going to see the signs of each of them within each quadrant. Alright, let's define another value here, which is r value. R is actually a radius of this circle here, and the r value is always positive. So if you consider this little triangle here, it's a right angle triangle, and if you remember from the Pythagoras theorem, hypotenuse square is equals to adjacent side square plus opposite side square, which is this value. So the r value here is the square root of the adjacent side square plus opposite side square, which is always positive. So in this case, we have cosine theta x over r is always positive. Sine theta y over x, y over r is always positive. And also on cosec r over y, r is always positive. The inverse, the reciprocal function of cosine is 1 over cos, which is secant theta, r over x, still r is always positive. The value that changes is only x and y values. So if you can see here, to the right of 0 value. So from 0 value to all the way to the right is always positive. The x value is positive. To the left of the 0 value is actually always negative. For y-axis, this is the y-axis. Let's assume this is y-axis. So the y-axis is vertical axis, and the x-axis is horizontal axis. So the value of y-axis above the 0 is always positive, and the value of y below the 0 is always negative. Okay, so at the first quadrant, sine of angle theta is its opposite divided by hypotenuse. Hypotenuse is always positive, whether it's quadrant 2, whether it's quadrant 3 or quadrant 4 is always positive. So the y value here is always positive because it's above the coordinate 0. So this at quadrant 1, y is always positive and r is positive. That means y divided by r, which is sine of theta, is always positive within this quadrant 1. If we see cosine function, the cosine function is its adjacent side, which is x, divided by hypotenuse. So as I said, the x value to the right of 0 is always positive. So this value is positive. X divided by hypotenuse, which is always positive. So the cosine function at quadrant 1 is always positive. Okay, so the tangent is still positive because sine is positive, cosine is positive, tangent also must be positive. So in this quadrant 1, all functions are positive. Alright, let's say quadrant 2. In quadrant 2, let's construct a right angle triangle here. So the adjacent side is x value here, and the opposite side is y. It's a right angle triangle with an angle of theta, and the hypotenuse is just a radius of this circle, which is always greater than 0. Okay, so as I said, in quadrant 2, so the value of y is always above the origin point, which is 0. This value is always positive, and the value of x is to the left of the coordinate, which is negative. Let's construct a right angle triangle here with an angle of theta, and adjacent side x and opposite side of y. So sine of theta is equals to opposite side y divided by adjacent hypotenuse, which is r. So y is always positive because it's above the coordinates, which is the origin 0. So that means y value is here always positive, and divided by radius, which is always positive. So sine of theta is always greater than 0 in quadrant 2. If you see cosine of angle theta, which is adjacent divided by hypotenuse, so the adjacent is on negative x-axis because x-axis to the left of the origin 0 is always negative. So a negative side divided by positive, that gives us negative. So x divided by r, which is less than 0. So tangent theta is equals to, so tangent is, as I said, sine divided by cosine, which is sine is positive, cosine is negative, then tangent should be negative because sine theta divided by cosine theta, which is always less than 0. Alright, So the reciprocal function is all the same. If sine of theta is greater than 0, then 1 over sine of theta, which is cosecant function, is also greater than 0. If cosine of theta is less than 0, then 1 over cosine of theta must be less than 0. If tangent of angle theta is less than 0, 1 over tangent theta, which is cotangent theta, should be. Next, let's say quadrant 3. So quadrant 3 is this region, which is this region. That means it's between negative x and negative y. So y is negative below 0 point. X is negative to the left of 0. So quadrant 3 is basically between negative x and negative y. Alright, so let's consider this the blue triangle, the right angle triangle, with an included angle of theta, adjacent side x, and opposite side of y. Okay, so sine of angle theta is opposite side, which is y, divided by hypotenuse, which is r. Y divided by r. So y is negative, as I said, is because it's below the origin. So this value is less than 0. So this is true for the reciprocal function cosecant as well. Cosecant is always less than 0 at quadrant 3. Let's see cosine theta. Cosine of angle theta is equals to adjacent side, which is x, divided by hypotenuse. So x is negative, this area, negative. So negative divided by r, which is always positive, is less than 0. So tangent, as we may understand, tangent value is positive because it's sine of angle theta divided by cosine of angle theta. That means negative divided by negative, which is positive, always greater than 0. So, and quadrant 3, only tangent is positive, the rest sine and cosine and their reciprocal functions are negative. In quadrant 2, only sine is greater than 0 or positive, cosine and tangent are negative. Alright, finally, let's say quadrant 4. So quadrant 4 is in between positive x-axis and a negative y-axis. Okay, so it's basically the blue hatched area. So sine of angle theta here is opposite side, which is y divided by hypotenuse r, y divided by r, because y is actually its negative value. As I said, it's below the origin 0, that should be negative. So sine at quadrant 4 is less than 0. Cosine of theta is equals to let's say this adjacent side divided by hypotenuse, which is x, divided by r, which is x is always positive because it's to the right of the coordinate 0, that's positive, divided by positive, which is positive. And tangent of angle theta is equal to sine divided by cosine, which is sine is negative, cosine is positive, so tangent should be less than 0. Sine of angle theta divided by cosine of angle theta is less than 0. So, and quadrant 4, so only cosine is positive. So how do you remember these things? In quadrant 1, all the trigonometric functions and their reciprocal functions are positive. In quadrant 2, sine and its reciprocal function, which is cosecant, are positive. The rest are negative. In quadrant 3, sine and cosine and their reciprocal functions are negative, but tangent and cotangent are positive. At quadrant 4, only cosine function is positive. Sine and tangent and their reciprocal functions are negative. So we can remember this in different ways. I would remember this as all students take calculus, like taking the first letters of all this. All the students take calculus, or all science teachers are crazy, or whatever you want it. So this is how I remember these trigonometric functions. But if you just take this example as a baseline, just construct simple circle, just construct triangles for each quadrant and try to calculate sine, cosine, and tangent function. That makes it life very, very easy. So thank you for your time, guys. If you like this video, just subscribe and like my video so that we can be families in the future videos. Thank you. Bye for now.